Wow. Oh boy. Hey, wait. Okay. I'm gonna. I'll do it next time. All right. I found yesterday. I think this is a very high probability. There's a bug in Zoom. By the way, can you all hear me? Because everything is slow for when I connect to Zoom, it's taking more time than usual. And then even when you guys are appearing on screen, there's a lag. So I want to make sure the audio is. Can you guys hear me? Can you guys see me?
Yeah.
Ashwat?
Yes.
All right, Keenan, Kai, I can't see them. All right, let me go. All right, so the bug I'm talking about is, see if I go to, so when I record the lectures, I don't want to, ideally, I don't want just the speaker view, right? Because in Zoom, you can get the speaker view and the gallery view. No, you don't know that? So in Zoom, on the type, on the right corner, you have view. You can either get a gallery view where you can see all of the students, or at least as many as can fit in one page, right? Or you can say, I want a speaker view. So it'll only show the active speaker. And so I try to get it in gallery view all the time. So we could all see all of us, right? Not just the one who's speaking, so that we can interact more fully. But then in the recorded video on YouTube, or the one that I download from Zoom, it's always, active speaker. So they're stitching it together differently on the server side than if I were to say, make the video recorded locally on my computer. Then the client side code they're using is different, right? They're not synchronized. So here, so before, you remember, because the previous videos, last quarter I used to record on my laptop. Oh, maybe the entire code is screwed up because I haven't tried it this quarter. All right, so I'll try recording on my laptop next on Thursday. Starting Thursday, and then see if it restores a gallery view. See, right now I can see the whole gallery. You guys can see the others too, right? Okay, so this is what I'm recording. It's recording in the cloud, but you'll see when I upload it to YouTube, you'll only see the active speaker and not all of you. So I hope it doesn't have any ramifications on the content we're teaching, right? I mean, so suppose Sean is coding something, and then Ashwath is doing something at the same time. No. Well, you'll be sharing a screen, in which case you'll be taking up screen. But yeah, the only problem is if we're all looking at your whiteboards and physical whiteboards, and then you're working out a solution there, and that's very unlikely to happen. So okay, so I think it's all right, but it's still a bug, right? I'll try and record on the local machine. All right. Well, I have some ideas regarding what to do today, because according to plan, we're supposed to start introducing arrays this today. So I'll talk briefly, very briefly, about arrays, what they are, how they're stored in memory. And however, and I'll show you how to create arrays in C++ also. However, in practice, right, it is very, very, very unlikely that you would use native arrays in C++ these days. Okay, so you would use dynamically allocated memory, or a class called vector that has been created for you already, which basically does everything an array should do in a much nicer way, right? It saves you from shooting yourself in the foot. Well, you can still shoot yourself in the foot, as some of my 2B students are finding out, but it makes it harder to shoot yourself in the foot, right? So yeah, that's we'll do arrays today. So I have some ideas, and then we can do that today. And I'm thinking what we'll do is we'll go to coding rooms, which I actually like so far, except for the slowdown and all, right? So we'll go to coding rooms, and then one of you can take, start off with me, because everybody's going to be coding in their own windows, right? We'll do the same thing as before, right? Everyone creates their own, let's say, what is today? 25 Jan. Okay, so it'll be Sean 25jan.cpp, right? Ashwath 25jan.cpp. So you create multiple files there, yeah. And then we'll pick one, any of you, and then that is what we'll edit on screen, right? With that person and me, right? And the rest of you can continue to edit your files. Not the same. You can do your own idea, right? So we'll do one idea, but essentially the idea today is that we want to be able to use arrays, right? Arrays. So we'll try a couple of quick examples using native arrays, But in order to do some fun stuff later on, right, where we'll each do our own things, we'll use vectors, not arrays. Yeah,
I'll turn my camera on in a second. I'm just fixing something up.
Yeah, no worries. Yeah, I saw it was pointing the ceiling, playing at the ceiling before. Hey, Noah, are you here? And Kai?
Yeah, sorry, I like low-key overslept. I'm just making some breakfast right now, but I'll turn it on.
Yeah, no worries.
I'm
You know,
in the
as long as I can
boat.
hear you. Yeah, as long
I'm
as I
just
can
eating
hear you.
breakfast.
Kai, I can hear you too, right? Was it you?
Yeah, I'm just eating breakfast. I'll turn it on once
Yeah.
I'm done.
Right. You just keep talking,
Okay.
and that's fine. So
Sounds
that
good.
you know, yeah, people will have a sense of more community, right? So that once we start doing things, everybody will feel that I've got my back. Someone's out there, okay? So if I'm stuck, I can go and ask this many people out there, rather than because it's happened in the past when students were coding and they bravely took the screen and then they were asking questions, but a lot of students were actually had actually checked out. All right, they only had these rectangles, and then that student didn't feel so good, I think. All right. Right, yeah, okay. Huyen, you're here, right? Huyen. I got it, but I will call you June, right? You wanted me to call you June, but I wanted to get the pronunciation right. So next time, right? June?
Yes.
June, okay. I'll practice more.
Good morning.
All right. Who else is what time is it? It's only 8:09.
Sorry.
Yeah, that's fine. It's only 8:09. You guys should just talk, okay? If you want to rope me into a conversation, that's fine. I'll do it. Because in fact, even though I'm going to do a little spiel about arrays, we can still start at 8:30, right? Or maybe closer to 8:30, even 8:20, right? So that we don't get moving before other people join. And that I think we should also encourage people to join sooner, okay? Not wait until later, because we can actually start earlier. Maybe starting from Thursday, we'll actually start coding at 8:10 or something. 8:10, 8:15. Will give us more time towards the end of class. Would that be better? We can actually start coding in 5 minutes. Yeah.
I think it's fine beginning on
Okay.
time.
All right. So we have one.
I'm sorry, I'm late today.
No, that's okay. Yeah. Hey, as long as you're talking, that's fine. Okay. You also, I don't know if you came in later, June. As long as you're talking, it's okay. I know that you're here. Yeah, is that okay? You don't have to have your camera on, right? Ideally, I recommend that you have your camera on later, whenever possible, because when the students watch the YouTube video, they don't want to click on rectangles. I told you, right? So they'll always click on videos with lots of smiley faces, and yeah. So
sure.
So that's a request that whenever you have afterwards, right? After you finish breakfast or brushing your teeth, maybe, I don't know, it doesn't matter, right? So when you sit down, just try and get
Sure, thank you. But my English is not so good, so.
Yeah. Oh, your connection is not so good.
No, I said my English is not so good, so.
What is not so good? Sorry, which list?
My English,
who cares? Who cares? Right? Sometimes I say things that even I don't understand. Right? So don't worry. We're not here to display our English skills or even math. Okay, math I can understand. Okay, math is related. Really, we are here to co-enjoy each other's thinking skills, logical, critical, rational, scientific way of thinking about things. That's what we're here to enjoy. Okay, it doesn't matter. So that's why I said, even if suppose we have a student from a country that I have no idea, and they're not able to speak English, and they're able to say, I have an idea, and I can gesticulate and show this idea. Or draw it on a whiteboard, and that is perfectly fine, right? Or because we're all here really just hungry people, because hungry meaning we're looking for interesting things to do, and anywhere we find interesting things, we're going to go, right? So yeah. So don't worry about it. Don't worry about English. Don't worry about anything. Appearance. Even if you're wearing bedclothes, right? So if you come here wearing your pajamas, who cares? Right? In fact, you watch the previous class videos, we had one student who actually attended class from bed. Right? He was, in fact, what's his name? I forget his name. He doesn't care. Yeah, he was got up in bed. Zaid, I think, if I remember. I didn't actually go back to the YouTube videos. He was getting up in bed, and he pulled out his phone and started attending class right there. Leaning back on his pillow. Who cares? Because and he had interesting things to say too, right? So that's what we want. In fact, you can attend class and not have interesting things to say formally, or you can attend class informally and have interesting things to say or show. Everything is perfectly fine, right? Because that's our mission. That's the reason we're having these, kind of class meetings, YouTube, everything public, is because we just want to have fun and show people that this is fun. Everybody can have fun too. Yes, this is computer science. It's actually an exciting, interesting field that everybody can get into. There's no barrier at all, right? Not even wealth is a barrier for computer science. We've said that so many times. That's the reason to get into computer science, because you don't need anything to do it, right? You don't even need to go and buy a notebook and pencil. Well, technically, it'll be much harder, but you can, strictly speaking, do it for nothing at all. So don't feel totally free. I think that is the idea. Yeah, and I'm glad we have a mix of students. Different languages, different accents, different ways of expressing ideas, because different cultural background, a shift can bring a completely different shift of perspective to a problem being solved. I don't know, maybe you guys are too young, you haven't encountered situations in which these things matter, because there are certain problems that will completely resist all kinds of attempts to solve, right? There's no possible way to solve it until you actually change your complete perspective to a culturally different point, because there are certain truths that were basically ingrained into us from very young ages that we basically assume to be blindly true and don't even question them. And so anything that appears to contradict that, our mind actually rules out as a possibility in our conceivable universes. So we don't even see the possibility. And so I've seen many times there are these deep fundamental problems that resist challenges. People are struggling and suffering to try to find solutions to those, right? But the solution is right there. They can't see it because they're blinded by truths that have been, not truths, that have been drilled into them as truths. And so they're not looking at the problem in the right way. All it needs, like in quest number 2 of Green, I think, right, which you will encounter, right, is you don't have to change anything at all, right? The physical structure can be exactly the same. But with the same physical structure, change the perspective and you get a completely different view. And you can see the solution, right? And that is one of the ways in which that's a clever trick, right? We use that to good effect in a tree-related problem in Green 2, right? If you keep going on with blue and get to green, yeah, is it Green 2? No, it's actually Green 4. So when you get to Green Quest 4, you'll actually be able to use that insight, right? In a real world problem in computer science, and see how that actually makes, because, try to do it without that insight, you will still be able to solve it. You'll still be able to solve the problem in the quest, but using a great deal of work, okay? A great deal of work will be needed to do it, patching up things here and there and so on and so forth, right? But just change your perspective and everything becomes very easy, because you can actually directly see the problem. That's what it is. That's what we need to solve, right? So, and delegation becomes easier, right? You say, well, if I want to insert this, and this is what I want, well, we shouldn't be talking about this now, right? Even, by the time in quest 9 of blue, we can start talking about linking and nodes, because these are the exciting parts of C++. I want you to get there as soon as possible. And yeah.
Professor, I have a quick question.
Yeah, sure. Zane.
Yes, if I could. So I noticed just in general, like when you're writing functions, that you can't, like in C++, when you do, like when you're returning a value, like an int or a Boolean or something, that you can't just leave like an else statement without, like if your entire
you can leave out the entire else statement. Is that what you're saying? Is it?
Yeah, I'm saying like if you have like an if statement and like you're checking a condition, you return something, you can't just only have that, correct?
Oh, you can. Totally, you can. The else is optional, right?
Right, that's what I thought. But then I was compiling and running the code and I was getting like an error, and then I ended up putting, forget what the error was, but I ended up putting.
Right, good. Remember that, Zane. I want us to try that today. Don't find the solution right now, right?
Okay.
Just think about what caused the problem. As soon as we start coding, we'll try and reproduce that.
Okay,
Yeah?
sounds good. Yeah.
Is that a good idea, guys? Right? Although we're going to talk about arrays,
Yeah.
we'll start off. Just a warm-up exercise, okay? Because this is stuff from if statements. We need to be solid on that. So let's use that as a warm-up statement, warm-up exercise, and see what the error was and try and figure that out. And then we'll do a couple of array examples, basic array examples. Okay. Again, me and that coder only, right? You can feel free to create your own files, right? But don't start working on your files yet, right? Because I don't want you to start editing your code already when we are still talking about fundamental concepts about, arrays and things like that. So, so you can, in fact, don't even create those files, right? So maybe it'll just be me and Zane on that tab, right? Or that file, and then we'll play around with that problem, and then a couple of array examples, native arrays, and then I'll also show how to use vectors, right? And how to create vectors. I'll give you some examples, right? This is how you get a new vector, right? This is how you size a vector. This is how you, and I'll put comments there. So you can basically copy and paste from that into your own code. Yeah, little comments that tell you what to do. Basically, I'm just giving you, here's what I'm doing, right? So in the first few classes, I gave you the basic Lego bricks, right? The little ones that, stick in your feet when you're walking on hard floor, okay? So those are the ones I gave you. And you've been playing around with it for a couple of weeks, I hope, okay? And try to say, okay, I'm really bored on it, right? So this is, give me some better Lego bricks, okay? So now what I'm going to do is now I'm going to give you stuff that has been made using Lego bricks, okay? But you don't have to put them together yourself. So you're going to ask me, give me, fire station, all right? Fire station, Empire State Building, and things like that, and I can give you. So let's say today I'm going to give you one chunk, right? And this is going to be a vector, okay? It's not native. It's actually something that's been put together for you, right? But you can use it in very nice ways as though it was a native type. And that is a really powerful thing. And really, if you get down to the nuts and bolts of it, right, you'll find out by the time you become a C++ master, vector is the bread of C++, right? No matter what complex algorithms you're going to use later, right? No matter what, anything. Even if you're going to build your own data structure, really complex data structure, right? Maybe you're going to build a 4D movie, right? In VR. Whatever it is, you cannot escape from vector, okay? So you're going to have to learn vector inside out, right? So from now on, from today, you can assume that you've been given this thing and you're going to take it apart piece by piece. You're going to analyze every atom of it, every moment you got, right? Look up vector, read about vector, look at every single thing you can do with vectors, right? What is the power of a vector? What are the things that I can do with a vector? All of these things, right? Think about it. And to make things better for you, before you start doing that today, we'll spend a little bit of time saying what's inside a vector. Although you don't need to know the details of what's inside a vector to use it, right? But I'm going to tell you what's inside a vector so that when you use it, you'll actually use it with a little bit of insight, right? And say, hey, you know what? That's a good way to use a vector. Does that make sense? Because the vectors out there and lots of people use it in bad ways too. I've seen it, right? So there's, even in Python, you take anything, right? Someone who doesn't know principles, someone who doesn't know what they're doing, will still get the job done, but they'll do it in a badass way, right? So not badass they'll do it in a in a shoddy way, meaning it's inefficient. They use vectors and they waste compute cycles. That's essentially, right? So they will get it done, but they'll get it done harder, right? And they may say, well, I'm not working. It's not just the CPU, right? The computer, your job is going to get done, but the computer will do it for you, right? So pay me, right? But that's not what you're paying for, really, right? Because ultimately, when you run it, it's going to be your computer that's running it anyway, right? It's your CPU cycles, right? If it takes 5 hours instead of 5 seconds, that's that much more electricity you're going to pay, right? So it's not enough to just get a job done. You got to get it done in the best possible way that conserves energy. So even if the energy is, is going to be going waste anyway, so a computer scientist thinks differently, right? So doesn't say, well, it's going to be going waste anyway, might as well do it inefficiently because it's the same, right? No real computer scientists I've met ever says that, right? They'll say, well, you know what? I've got like so much CPU, but I only need so much. So I can do a really lazy job and use all of that CPU and do my little job, right? Or I can just do my efficient job, right? Which means I'll only end up using 5%, but Amazon gave me 100% for free anyway, but I'm only going to use 5. What can I do with the remaining 95? Well, I'm just going to let it lie, right? Just because just because I've got 100% CPU, I'm going to use all of 100%. That's not the way a CPU, as a computer scientist thinks, right? Even though you can get it done. And so that is why I think it helps to know what's inside the box before you start using the box blindly. And so today and this is the only chance we get, okay? I think, yeah, right. We'll do vectors and classes. Yeah. All right. So this is the only chance we get. Okay. I'm not going to come back to talk about arrays again, unless you guys have any pointed questions and, set up meetings and talk about this. Right. So this is the only chance we're going to use this video to talk about what's going to be inside of a vector. Okay. And what an array is and so on. From now on, we'll just say, use a vector, use a vector, use a vector. What I mean is, well, let's just use an array. Yes. And in fact, using a vector will be a whole lot easier for you too. In your code. We'll see, right? There's going to be so many examples. And the reason I say vector is a bread is that it's just going, everything else is like, you're going to be, it's going to be built around it. So everywhere you're going to be using a vector. So, so that is fantastic. And we have a lot of time in the class now, right? This is only week 4, and you'll have a lot of chance. In fact, you're going to be using a vector a lot in class number 6. Maybe 6 or 7. Class number 7 onwards. In fact, from 7 onwards, you're going to be using vectors for the rest of your life. All right. Okay. As a programmer, after you complete quest number 7, there's no way. Well, contrived little ways, or maybe there are problems that don't require a vector, but more likely than not, by the time you get to week number 7, that's it. You cannot. Vector has been tattooed on your forehead, right? So. No, on your forearm or something like that. Okay, all right. So how about now, right? Actually, we have been, keeping the airway occupied anyway until our usual time, but we'll try and start sooner later. So how about someone, maybe Zane, right? If you want, Zane, can you take the screen and then go to that link? I think Keenan shared it. Where's Keenan? Oh, there you are. Okay. So yeah, if you can just go to that link, I think it must be in the chat window because I just see that badge on the chat. Right? So
okay, yeah. Let me.
Yeah. No problem. Yeah, thank you. The same as what Noah did last time, except we'll do a different file, right? And then your main.cpp, call it a Zane 25gen.cpp or something like that. And then you guys can create your own files, not now, okay? So after we've done talking about arrays, you can go and create your own files.
It's in the chat, Professor. You said? Oh yeah.
Oh yeah, it is. If you go to the chat, I think Keenan had a link. I saw it flash by before, so I think it was a URL. So just click on it. It should go to that. Maybe you even get a file already. Just rename the file to.
Yeah. Okay. Let me.
And I think Keenan sent the link. So while you're doing that, Keenan can also add all the other people as editors, so we can save some time.
Can you see it?
Yeah, I can see it. No, but this is the old file. Oh no, this is the old thing, right? So what we want. Oh, I see. There's no way to get rid of this, huh?
I mean, we can delete all the files.
No. In fact, this is what we'll do.
It's just like a digital workspace, I think.
Well, no. Hey, actually, no. This is good. Don't worry. Actually, because well, why do we need to save these files, right? Why do we need to snapshot these files? This is Keenan on 24th, and this is Keenan on 27th. Who cares, right? So what we'll do is every person will basically just delete what they've got and start again. And you don't need to have one. You don't have to timestamp your file. Just call it Zane.cpp and Keenan. Right? Who? Right? And I think it also looked much better on the left, right? Without all these dates. Well, you don't even need the 2022, Zane, because what are the chances you're going to be in a similar situation?
Yeah, I just see the 2022 on everyone, so I was like,
yeah. But make it Zane.cpp, right? We'll just do, and then everybody can follow your example.
Okay.
No, I think you have to right click and there.
Yeah, I'm trying to. Can I delete it? You just make a new one.
Yeah. All right, cool.
Okay.
Excellent. All right. So everybody okay? So let's just create a very basic template, and then Zain, okay, let's reproduce your issue with some basic, very simple if statement. Well, we'll just we can come up with one, right? If you or me or Fernando.
Yeah, I'm trying to think. I'm trying to remember what it was because I did it a couple days ago.
I'm gonna walk you through this if you don't mind. Yeah, I'll just say,
sure.
and so until you're comfortable, just turn into a robot and type what I say.
Yeah,
and at some point, something will kick in and say, okay, I don't have to listen to Anand anymore. I can just go and type on my own. Okay. All right. So hash include. All right, and then angle bracket that's less than, yeah, IO stream. All right, so that is our basic, we're using all the functions that, we anticipate we're going to use these, okay? And then you say using namespace std semicolon, save us a bunch of typing. Yeah, all right, and then a couple of blank lines. And then this is a standard signature for main. We'll always do this, all right? So int main. And then let's just say open parentheses, close parentheses. This is a version. There are two kinds of main, okay, in C++. One is a parameterized main where, things get given to it by the operating system. We're not going down that road, but there is actually a quest, and we've talked about it, and there's recordings in our YouTube channel, right, from past classes. You can. So, but we're not going to do that. This is the only version we need to remember, okay? Because I figured, this is what is necessary for us to understand the concepts. All of those other things are icing. Okay, so after the closing parentheses, one space. After the closing parentheses, yeah, one space. Yeah, and then curly brace. Okay, and then one more blank line. All right, on line 7, say return 0. Okay, so that is our basic template, and that is a fully functional compilable. It'll compile and run, but it won't do anything. In fact, to make sure that you can test it out, instead of return 0, say return 5 or some number you pull out of thin air, right? Just pull out a number out of thin air and say, all right, now run it.
Oh, I think it's running someone else's.
Oh, you have to right click and say run Zain.cpp or something. Not there, maybe Zain knows it. Hey, Keenan, how does he run his own file? Oh, you have to click
use the drop down and click run Zain, but I don't think it'll tell you that it's ending with 5 on this.
No. It should say, oh, it doesn't give you the exit status?
I don't believe so, no.
Oh, but I thought it did. It said your program exited with status 5 and something like that. I thought it did that before. It's a different site. No, that's if you run it, you're running someone else.
I don't think it
I know.
on this site.
Yeah.
Let me see if I could enable that in settings or something.
Oh, actually, no, don't worry. It's okay. Hey, Zain, don't mess around. One sec. Okay. All right. I'll just show you what I mean, okay? But that's going to take 2 minutes. Oh no, 2 seconds, okay? And we're going to come back here. You're not going to mess around with finding out why it's with the exit side. All right, just Command A or Control A and copy the whole thing for a sec. No, not there. Here, okay, all right. Okay, good. Have you got it in your clipboard? Okay, Command tab. Now open a new tab. Open a new tab in your browser. Right, just go to onlinegdb.com or cpp.sh or something like that for a sec. Oh no, I think it's onlinegdb.com. B as in book.
B?
Yeah, db.com. Right. All right. Now all right, here, just Command Control A and paste your code instead of this one. Actually do Control A. Control A will get rid of the whole damn thing. Control A. Doesn't do it? No, paste it. Command V. No, Control A and then Control V.
Oh, I see. Okay.
All right. Now, if you run it, it should say, this is because I remember it some environment that told us. So why is it taking this long?
No, because you need to choose the language.
Oh, you have to choose the language.
Right.
Oh, it's waiting for you. All right. Choose C++. Choose C. No, on the right. You say choose language. Okay. There you go. On the right.
Yeah. It was just blocked by the Zoom.
There you go. Now it should run and it should tell you what it is. What? Exit code 0? It said exit code 0?
Mm-hmm.
How is that possible? Just say exit 5 instead of return 5. Just instead of yeah, exit, and then the 5 has to be within parentheses. Yeah, put the 5 there and get rid of the other 5. Okay, now run it.
It's loading. Oh, no, no one saved it. Weird.
Wow. What's going on here? So this is weird. Okay. All right. No, just go to cpp.sh and run it. So maybe there's a bug here. Maybe they're giving you a container and giving you a different exit status, or something is lost here. Just you have the whole thing in your buffer, right? Just another tab. Go to cpp.sh. One more browser tab.
Yeah.
Hey, your browser is now. You know, I can't see the screen.
You see
Yeah.
it?
Now I can see it. Yeah, just do the same thing. Control A and hold, and then paste. Control A and then paste. Yeah. All right, run it now.
Do you want exit
Just
5?
hit, no, just hit run.
Okay, where's run?
Oh, on the bottom right, bottom right.
Oh, okay.
I can't see the console. Where's the console? Your browser is.
There it is.
Exit code 5. Great. Now change. Oh, you return 5. Exit code 5. All right. So this is okay. This is working. Okay. This is working. In fact, if you go back to your CP your coding rooms, I'll show you. Right. Go back to your coding rooms tab. All right. Now here, do an ls space -l in the black part in the console. Right. In the console, do an ls space -l. Enter. Do you see Zane.cpp? All right, we'll just compile it by hand, because we'll compile it by hand, and I'll show you where that exit status is. Right, you have return 5. Great. Okay, now increase the size of this black part, so the console, just make it bigger vertically so that we get a decent console there. Because I'm going to walk you through the steps here. It's actually fun and interesting and useful. Okay, otherwise I won't tell it to you. If you don't want this, say, hey, just cut this and let's go back to this code. I'm happy to do that. Okay, so I'm telling you this only because it's useful. Let me know if not. Okay, so let's compile this by hand. Okay, it's a very useful skill. G++. Okay, -o. Okay, space Zane. Is that Zane? Yeah. Okay, Zane space Zane.cpp. I say capital Z.
Oh yeah, so we're naming
Capital
it.
Z and tab, hit tab. All right. So when you get into the habit of hitting tab, it'll autocomplete for you, right? Yeah. Tab. Z tab. No, Z tab. Z. You got to tell it. It starts with a Z. Z. Type a Z. Type a Z. No, uppercase Z. Right now, tab.
I see. Okay.
Okay. Yeah. All right. Now, yeah. Okay. That's it. Now, if you do an ls-l again, which you can get by 2 up arrows, hit 2 up arrow keys. No, just hit one more up arrow. One more. There you go. All right, so it's in your history. So you can get it back from your history like this. Enter. Now you'll see a file called Zane. There you go, it's green. Yes, let's run the file and say ./Zane. Okay, now it ran and it exited and you don't see anything. Yes? However, something has happened, right? And something has happened which cpp.sh showed us, but this site doesn't. Where is it? Okay, we'll find out. Now you do echo, ECHO, space, $, all right, $, and then question mark. Okay, now this is a special variable in the shell, okay, in which the operating system will put the value of the exit status of the most recent command you executed. Okay, we don't know this, it's in the Unix documentation or Linux documentation, but this is a special variable which stores the exit status of the most recent command. So if your command that you ran doesn't actually print out on blurred out on the screen saying, okay, this is my exit status, this is where you can find it. Is this useful? Okay, I hit enter, you'll see 5. All right. Now, however, now if you repeat the same command, now don't do anything. Okay. If hit up arrow. Okay. Now, what do you think is going to happen? Anyone can answer this. Okay. What do you think is going to happen when Zane hits enter? Okay. I think it's an interesting question. Okay. It's only marginally related to C++, but I think it's useful. Okay. Do you want to answer this or not? What is going to happen when Zane hits enter? Or what is it going to print? What value is it going to print when Zane hits enter? Take a guess. Okay, take a guess. Doesn't matter.
5.
5.
5.
5.
Okay, very good guess. Who said 5? That's a good guess.
Sean.
Sean, okay, 5. Yeah, that's a good
I
guess.
also
Any
said
other
5.
guesses? 5. Oh, Noah's 5. Okay, so yeah, I can explain my reasoning and we'll check, right? That's how we do it, right? So we have guesses, and I think the answer will be 0. And here's my reasoning for 0. And both Noah and Sean have valid reasons. They said, the most recent command I ran had an exit status of 5, so it's there in 5, and I haven't cleared it. 5, yes. So it's a valid, very valid argument. But my argument is going to be, well, you know what? I'm the shell. I'm going to put the exit status of the most recent command that was executed. The most recent command that was executed was not Zane, but actually echo, right? And echo was successful. It didn't fail. And if it was successful, its exit status would have been 0, not non-zero, right? Because in the operating system that we're used to, only failures have non-zero codes. Everything else okay. No news is good news. 0. Yes. So if you hit 0, if you hit enter now, I predict the value is going to be 0 and not 5, which is a surprise, right? Because everybody, thinking like we humans do, we're going to say it's going to be 5, right? That's what I would have said too, right? The first time I did that, I was totally surprised. And when I realized that's what was going on, I was totally floored, right? I thought, wow, that is the nugget, right? That's a golden nugget that's hidden in the landscape of C++. There's so many like this that you'll find and appreciate, right? And then you'll find, you'll have a huge inventory, right? So you'll never feel bored. And you can say, wow, that was nice. That was nice. Yeah, well, all right, tomorrow, let me think about that and things like that. Okay, so hit enter. I think you'll see 0. All right. So in fact, you can force a particular value out there too. We won't go down to it, right? So, but this is useful. This is useful because whatever you're learning in C++, you can also use in the shell right here, right? So you can use if statements in the shell on the command line. Lots of people just interact with the shell but the shell, you can actually program this and interact with it. You can use if statements. But what is an if statement to a shell? So at the shell level, an if statement is, if the following command succeeded, do this. If the following command failed, do this. How is that? Right? So you can write that kind of thing here. In fact, in the shell, you can even write a loop statement that says, I have a command. Keep running that command repeatedly until that command fails. How about that? Yes? So we can do this right here. Hey, Zane, type this, right? Okay, so I believe
in the console or the shell?
Yeah, in the shell. Is that okay? Because it's very similar to what we're going to be doing in C. Oh, did you hit Control L?
Did I what?
No, it went right to the top. I thought you hit Control L because that's shorthand for clearing the screen.
Oh, no.
I thought you knew that.
Yeah, there's like a console section and then the shell section. I don't know what the difference is.
But hit Control L, we'll see what happens. Nothing happens with Control L?
You want me to clear it?
Well, that's fine. You can if you want. All right. So what we're trying to do, we're going to do a very basic looping statement in the shell, which is very similar to your, looping
Professor?
constant. Yeah.
There's like console section and then a shell section. Like
Yeah,
on
I don't know. I also
top.
wondered about that. Who was that, Sean? Did you say that?
Yeah, that's Sean.
Yeah, I kind of wondered. Click the shell tab. We'll see what's in there. It's exactly the same.
Yeah.
All right, okay. But do an ls-l. Maybe a shell is basically a shell in a different directory, right? Maybe the console is where you are. Do the same thing in the shell tab. Maybe you have different.
That was the shell.
No, that's the console tab.
No,
I do the same thing in the console tab. ls tab, yeah. It is the same. It is the same. They're just calling it by different names. All right. I think that's my hypothesis. And so the looping thing we're going to do here is there is a command called true. Right. It's a cool thing about Unix and Linux and these things. And these are useful commands, right? Not for these are commands that exist, not for the heck of it, but they're real commands that people have written for very specific purposes. There is a command called true, and there is a command called false. Okay. In fact, you'll know that there are 2 files in the operating system. So do an ls-l, ls space -l space, right? /bin/true, right? /bin/true. Yeah, enter. Yeah. There is a command called true, right? And what does this command do? All it does is exit with status 0. That's all, right? One line. What Zane is the command that Zane wrote, exit status 5, right? If he had said exit status 0, that is this command, right? But what Zane wrote, exit status 5, is not this command, this is exit status 5, but false. If there's another command just like this called false, all right? Run false, or do an ls-l up arrow and then change the true into a false. You'll see this other command called false, right? That always exits with status 0. If you run the first command, the exit status will be 0. If you run the second command, the exit. So what we're going to try and do is write a very simple loop that's going to run the command, okay? And while the command is true, right, it succeeds, you're going to do something, okay? So say while, okay, now say true. In fact, don't say true, because true looks like a keyword. Say /bin/true. That way it's clear that I'm running a command called /bin/true, right? It's not a keyword, okay? Yeah, okay. And then say semicolon, okay? Semicolon. And say, I think this is a syntax. This is a very long time since I've forgotten in shell, done in shell, right? Say space do. I think it is do.
Are you supposed to put a semicolon after a while?
You know what? After while been true, hit enter. Don't do. It'll just give us a continuation line, right? Okay. Right. I think you do need a do, right? Zane, I've forgotten, right? Let's type a do. It's just a different syntax, okay? Everything is the same. Whether you go to Python or Java or C++, it's all the same. That's why I'm not feeling too bad about wasting time talking about this. Is that okay? Because we're just talking about the concepts here. Okay, good. So do. And then hit enter. All right. Well, and say sleep one. In fact, say /bin/sleep one. All right. So let's make it very clear that it's actually a command, just like a C++ function. Each command in the shell can be interpreted as though it is a function in C++, which you'll write very soon. Okay. So all right, and then semicolon there, and then space /bin/echo. Right? There's another command called echo, right? Space, and then say slept for a second.
Like a string?
Yeah, space slept for a second. No, it doesn't even have to be a string,
okay.
right? Because it's in the shell. Everything is a string in a shell. All right, now say done. I think it's done. I think, yeah, all right. Yeah. So it's actually an infinite loop. And it's going to keep running until the command bin true fails. But when will bin true fail? It'll never fail, because the only thing it does is say, oh, well, I'm going to die a happy death. Yes. Always exit status 0. So it's always, so the thing is, when we use these commands, you just have to be a little careful that you don't overload the system, because it's always going to be true. So you got to have a sleep like that, or else you're going to hog all the machine cycles and all the other users will be unhappy. Right? In this case, not so much, I think, because it's going to be a container and they'll just kill it. But still, generally, it's better practice. Everybody okay with this? Yeah, this is an infinite loop, right? What we studied last class. Everybody okay with this? Was this useful? Right? Say yes or no if you think this was useful.
Yeah, wait. Can you tell me again what the sleep does again?
Sleep is a command which basically sleeps for n seconds. You can say sleep 5 and it'll sleep 5 seconds. It won't. Basically, sleep meaning it'll just lock up. If you're in a loop and you're doing a lot of things, right? You can say, kill this, hit Control C. Did you hit Control C?
Yeah, it's not.
Why did it not? Why is it not giving you a prompt again?
Oh, it's still going. Wait. There we go.
All right. Okay. Just clear the screen. Sean, you had a question. I forgot.
The sleep, but.
Yeah. Just say sleep 2. It'll just sleep for 2 seconds. Just say sleep 2. Sleep is a command, and you can also write it. Okay. All sleep is doing is basically running off the system clock. It'll set an alarm for that much time, and it'll basically sleep. All right. So if you say sleep, no, not this. No, kill this. Kill this. Control C. All right. So just say sleep. So just say /bin/sleep. That's a command, right? And then say 2, right? All right. It's basically just going to lock everything out for 2 seconds. Yeah, it's useful. There is actually something called micro sleep or nano sleep, I think. I don't know, right? That lets you sleep for fractional times, but you can only do it in code, right? This is the command line version for humans to interact with. So one is the granularity. But if you're doing it in C++, you can sleep for nanoseconds too, I think.
Okay, thank you.
Does it make sense?
Yeah, that makes sense.
All right. So if everybody is happy with that, let's go back to the code. I said it's going to take like 2 minutes, but I think spent a lot more than 2 minutes talking about this. I hope it was useful. I'm sorry. Well, you guys should just feel free to cut me off, right? And say, let's go back to that code. We can go back to the code anytime. So let's see. Main. All right. So we got. Yeah. Sorry.
It was interesting.
Oh, you have a question, Sean?
No, I just said it was interesting.
Oh, cool. All right. Thanks.
Yeah.
Thank you. All right. But sometimes when it's not interesting, you should just feel free, right? I know sometimes I say interesting things, but I know sometimes I also say not interesting things, and meaning not interesting to others, right? Could be interesting to me. How do I know? Right. So sometimes when I do that, I have to rely on you guys to tell me, right? So, hey, it's not interesting to me, right? So can we move on, right? So that's perfectly fine, right? Because that's the kind of useful feedback for anyone, right? Even for a machine learning system, if you're going to interact with AI in the future, right? The only way you can get a better experience from these machines and robots is by telling them what you don't like, right? Just like humans, right? When we have humans interact with humans, and we treat them with respect like we treat a robot, right? Because ironically, right, we treat robots with respect, but many humans are not treated with respect, right? So if we treat humans with respect, we're basically going to say, how do we start talking about this? I don't know how we got started talking about that. Yeah, this is what I mean, right? When I digress, you got to yank me back in. Sometimes, yeah, if it's not interesting, I'm sorry. Yeah, if it's not interesting, we talk about it. But if we get political correct, not political, right? Where you have to be kind. But if we get irrational things get in the way of giving good feedback to the other person, then you're shortchanging both parties, right? Yourself, because that behavior is not going to change sooner than later, and that person, because they're going to waste a lot of energy telling you things that you're not interested in, right? And in my experience in life, what I've seen is many of the big fights, right, in relationships and so on and so forth, may not even have happened, right? Because when I look at it and think about it and trace things back, they're actually not, they're just retaliations. They actually started off as something really simple, right? But something really simple that annoyed the other person. But instead of saying that annoyed me, if that person said, well, you know what, I got it. If I say, I just can't say, I can't give it up. I can't make a small compromise. So I got to retaliate by something bigger. But because this thing wasn't seen, they're going to retaliate with something bigger. It's all subconscious, right? Nobody sees that happening. They only see that after it crosses a certain threshold, right? At that time, the retaliations are too big for anyone to make a comfortable compromise, right? So the compromises get harder and harder to make upstream. And that's really what happens. And all of that, I see 90% of that can be prevented if we basically just say, right, we just have to feel comfortable, right? Saying that, you're not interesting, let's just move on. Right. And I don't think anybody's going to be offended because there are so many other things about the person that are enjoyable. Right. I'm pretty sure sometimes I say useful stuff. Right. I mean, it's not like 100% of my lectures are not useless. Right. Maybe that's 50% of my lectures where you can actually get useful stuff. I know you guys are coming back and not just for the points. Right. So there must be some interesting things that I say, but you can feel free to toss all the non-interesting things. Right. And I think you'll have a great time. But you've got to tell me. You got to tell me, right? Because that's how I can improve. Also sharpen, right? Because sometimes I have useful stuff to say, and I fill it up with fluff. And so the point we want to make about arrays and dynamic memory or something like that, make it diluted. So maybe these conversations are best kept separate, right? Have a separate meeting to talk about that shit, and we can talk about arrays here. That makes it better for next quarter, right? So you'll be helping next quarter students by telling me that, so that I can better demarcate these things. Anyway, that's where we're going. Hey, Zain, what I'm going to do is everybody okay? We can proceed by coding in here, and we'll start working with native arrays right now. Yeah, and then I'll introduce vectors, and you guys can go away and do your own vector little problems or puzzles. I'll give you lots of ideas to do. And we also have Thursday to play around with vectors. Okay, this entire week is about vectors, and hopefully you'll get to question number 6 or 7, which uses vectors, and you get a lot of chances to play around with vectors yourself. Okay, so hey, what I'll do? Yeah, sorry, go ahead, Zain.
Yeah. So are we? Is that what we're gonna do right now?
I think so. Yeah. Let's just do not vectors, right? We're going to do arrays right now.
Arrays.
Right?
Yeah. Okay.
Yeah. In fact, I'm going to change my glasses. So you got half my screen right now. Hang on. I think I can see you already. So that's better. Okay, that's much better. Oh, all right. So don't change those sizes. I can see all of you, right? So I don't. Yeah, you're not scrolling on, so I can see all of you. That's great. But yeah, I think hopefully this will get recorded. Even when this is recorded, because it's on the cloud, it'll just show the screen full, right? And then the active speakers and a small icon on the top. So we can't see the whole class. Next class, I have to remember to change that. So we record the whole thing like this. Okay, all right. So what we'll do here is put a comment there on the first line. Yeah, and indent the comment in because it's part of main, right? Everything under that, let's just say that is the margin, right? Yeah, that's the margin. And we'll say declare a native array of 100 floating point numbers. Okay, let's say 10 floating point numbers. All right, 10 floating point numbers. On the next line, say that on the next line, yeah, say this array in memory ought to occupy 10 times 4 bytes, right? Because each floating point number is 4 bytes. Yes, yes or no? I'm not getting any feedback. Right? Most architectures that we use, right, floating point numbers are 4 bytes long, and we'll find out, right? We'll find out. In fact, I will show you, right, how we can find out. On the next line, say comment. Let's find out. Let's find out how big a float is. Okay. On the next line, you're going to say cout, right? You say within quotes, you say size of a float on this machine is within quotes. No, you had the right thing. Left shift was right. Right? You say the size of a float. The size of a float on this machine is. Okay. All right. And then after the quote, left shift again. Right? And say size of. SIZE of one word. Right? And then say float within parentheses. Right? And then semicolon, and no, not semicolon, you got to do an end line and then semicolon. Right, run it, you'll see how big a float is.
Or
yeah, so size of is in fact not a function. I thought it was a function during my very early days of C++ programming, but it's not a function. It's actually a compiler directive, right? A compiler directive is different from a function. A compiler directive is something like one level up from a preprocessor directive. There's something called a preprocessor directive too, something that happens even before your compiler. It's like, you know, when you eat food, there's a pre-digestion process, right? It's got to be mashed by our teeth, and then it's got to be mixed with the right amount of saliva, right? All these things, like, you know, a sequence of processes has to happen to the food that we eat, right? So like that, when you write a program, a sequence of things has to happen before it actually becomes executable code, right? The first thing that has to happen, obviously, is that, you know, there's something called a preprocessor that will, it's called CPP, right? And I'll show you, right? In fact, in the console, you can say man space CPP. It'll tell you what the C processor is, right? It's the CPP doesn't stand for C++. It actually stands for C preprocessor. Okay, what C pre? In fact, if you do man CPP, it'll just print a whole lot of information about CPP, right? No, man space CPP, right? Say man space CPP there. Not there, in the black, in the console. Not echo, man.
Typing echo.
Why is it typing echo?
Yeah, I'm not doing that.
Someone else is typing echo. Man, can you type man? CPP space say space CPP. No, just man space CPP.
Like
yeah, enter. Yeah.
All
right, okay. So it is actually a container, and they actually created a Docker container by, you know, giving you a basic no-frills Unix machine, removing everything you don't need, right? Just like I do in, you know, questing, that's what I do, right? You need a proper box to run your program, but there's a lot of things you can do in that Unix environment that could shoot you, shoot me. It could be damaging to a whole lot of people, damaging to students. So I basically just gave you a container that has been stripped bare so that you cannot basically do anything bad in it. Right? But you're free to do anything you want in it. That's what I do, right? And that's probably what they're doing. That's why when you say man, in fact, it's interesting, isn't it? Even though they give you this, they give you a shell and some commands too. We saw they gave you a whole bunch of commands. But even I don't do that, right? I don't give you even these commands, right? So they're very nice. These coding room people, maybe they have a lot of, you know, free cycles to spare, but they're giving you a whole lot of things. You know, we can go there and run these commands. That's really cool. So anyway, so CPP is a command that someone has written just like you, right? It's a C program that basically takes your program that, you know, Nate's written here, not Nate, Zane, right? And he's going to read that program and say, well, you know, the compiler needs to compile it, but the compiler is a busy person, right? So I can't just give her this whole thing. And what I need to do is, before I pass it on, I got to clean it up a bit, right? That's what you do, right? When you, as the message is passed to higher authorities, it gets cleaned up, so all the fluff is removed, right? Eventually, when Joe Biden looks at the final recommendation, it's going to be, well, this is the summary of that. This is the final recommendation of the council, right? Something like that, right? So he's not going to read it. Well, he does, right? I mean, the story says that Obama used to read like 500 pages of information frequently and things like that. But, you know, presidents do read these things. But I'm saying that generally what happens is that, you know, as and when time becomes a precious commodity, delegation happens. So saying that, you know, I'm going to trust you guys to filter this and give me the real stuff, so I can just look at what is important and make the critical decisions, right? That's usually what happens. So here, the preprocessor is one of those servants for the compiler. This is Mr. Compiler or Mrs. Compiler, your time is so damn valuable, right? We can't take any of it. So we're not going to overload you or, you know, make you deal with comments, right? Who knows? Maybe Zane put in like a ton of comments there just to help him and all his fellow students, but you don't need that, right? So the preprocessor does a whole lot of things, okay? The preprocessor will strip all the comments. Okay. In fact, many times in other, maybe in C++ and other languages, the C preprocessor also shortens function names. Right? Because, you know, if, you know, Kylie writes a really huge function, right? Maybe it helps her saying, well, you know, take this string and count the number of vowels in this string. Okay. Yeah. Maybe you write a function like that. And it's a long function and it's called that, you know, count the vowels in the string, right? Well, why does the compiler need to worry about, you know, all these things, right? It just has a bunch of instructions to follow, right? And there's something called that long name. Okay. All right, so it just needs to remember long, well, you know, Kylie wrote long name 1, okay? Right, if someone else writes another long name, it's going to be called long name 2, as far as the compiler is concerned. Yes, it doesn't have to remember the individual name. So it has an internal table, it's called a symbol table. It does this mapping. Well, that happens at the compiler level, but I'm pretty sure that can also happen at this preprocessor level, because it's really cheap these days, right? To do it, you can just write it in Python or even in PHP, symbol table mapping, and you'll write it, in fact, you know, in cs2c, you'll write a hash table yourself. So what was I going with that? Yeah, so the preprocessor will take, so what the compiler sees is just that. However, the compiler actually sees a lot more than that, because when you do the hash include, there's a whole lot more of really useful stuff too. That's in one of those include files, right? The preprocessor has two things to do, right? It has to clean up your code and also include all those other things. And then the final package is what it's going to deliver to the compiler. Is it okay? Does that make sense to you guys? Yeah. So does this tie in the experience of what's being coded there and what's being run here and so on, right? Because it's important to, because many times I've seen during early stages of programming, students who are just made familiar with a programming language through an IDE exclusively, right? And I've seen that, right? Programmers who have only programmed in Java using Eclipse, right? Or VS Code or Xcode, and you can actually do it. The irony is that you can do a lot of stuff without getting to the command line, right? But getting to the command line and knowing what actually happens in the background is going to be a critical mile in your development as a programmer. And many people are actually missing that, because they can still do a lot of stuff just in the IDE and things like that. But you can see that they're doing it the hard way, right? Because, you know, like I said, there's easy ways and hard ways, but when you have, and you know it's a hard way, because you're saying the IDE is actually eye candy. Do you agree with me or not? Any IDE, any fancy thing you get, really is just eye candy. What did I call eye candy before? Syntactic sugar, right? Syntactic sugar. You don't need it, yes, because technically you can just program in ones and zeros, yes or no? Right?
Yeah.
So you don't, yeah, so you don't need the IDE. And so you're saying, well, you know what? It's only a nicety. It's a vitamin pill. So I'm going to take it anyway, even though I don't need it. Right? Which means that you're willing to buy it. Even though you don't need it, you're willing to buy it and take it. So if you're going to buy it, you're going to give up something for it. You're buying it, right? It's exchange, a quid pro quo. So because you're taking the nicety of the IDE, you're going to have to sacrifice something. And that is speed, which many people don't notice. Right? So the more bare bones you go, meaning the more comforts you can forego, the more power opens up to you, because you're not beholden to those comforts in order to achieve what you want. I don't know if that doesn't make sense. because everything you're beholden to, everything you have a dependency on, basically holds you back. So it's okay to use an IDE to simplify your work when it's needed to do the job properly. But many people don't get past the notion that, or get to the notion that an IDE is just a nicety, right? It's not a critical must-have, right? Lots of people think it is a must-have, and that is why a lot of people who are actually experienced programmers who did not use IDEs when they first encounter IDEs. I actually know people like that, right? In fact, I know a young guy just like you, right, who did use to program very complex stuff without an IDE, and just discovered an IDE yesterday, well, last week, okay, VS Code. And even though they knew about, Xcode and all these other things, they never used it. And then they finally had to bite the bullet and decided to use VS Code, and it was. And I had a phone call, and the person was blown away, right? Wow, I had no idea you could do all this, right? But still, that is a nice kind of surprise to have, rather than just get spoiled already with the IDE on day one. And but I'm not saying you shouldn't, but you should still use an IDE, but you should also try and do things the hard way like this, to know what's going on, and also to get a better appreciation of what is being given to you by the IDE, right? Because we just take it for granted, but we don't know that it's doing all this. Yeah. So it's good to know that these things. All right, thank you. Enough of a digression there. And I again see another example where nobody just butted in and said, "Let's get back on the road." Okay, so there you go. So that is how you find the size of a float. Now triple click on line 9. Triple click on line 9.
One sec. Triple click line 9.
Three rapid clicks. Oh, good. Don't do anything now, right? Control C. Is this a Windows machine or a Mac?
It's a Mac.
Command C. No, to do a triple click and then do a Command C.
Yeah, I did.
All right. Now, why? No, I think, but then you clicked again because the blue color is gone. No. Just get rid of this. Command Z. I want to show you an easy way to do this. Okay. I'm sure you can do this way and clean up also. All right. Just triple click. All right. Command C. Don't do anything more because I want the blue color still there. Okay. Is the blue color right now? All right. Now, without doing anything more, just hit a Command V. Right. Now, what it's going to do is going to paste this line over the same line for one key click. You've got what you want because you want to be at the beginning of the next line, right, before the return. Right. Imagine if you had to do the paste and then you have to do a bunch of fine movements of the cursor to get there. But just by doing these two keystrokes, you've got there now. Now do one more Command V. Okay, good. Right. So for 4 keystrokes, you've got a duplicate of the previous line indented correctly. That's what I mean. Yeah. So sometimes I know students say, this prof is a pain because he says, this very particular idiosyncratic ways of doing things. You don't have to do it this way. Okay. I'm just showing you one time. Okay. And I'm not going to be annoyed if you don't do it this way. Because I could say triple click and you can just do the thing you do, but you know what I mean. That's what I mean. Okay. And I'm just showing it to you because as you get faster and faster in programming, if you don't know these tricks, you'll find that you're being held back. Okay. You're not moving as fast as you'd like to go because right now, maybe you're going slower than you'd like to go. Okay. And maybe you just remember this feeling because you'll forget this feeling. Okay. It's hard to remember this feeling. Okay. Now you're going slower than you'd like to go. Okay. At some point, and it's the opposite. Okay. Some point you want to be able to go fast as you can go, right? Your mind is going much faster than your body is able to do. Okay. At some point, you're going to get there in C++, any skill. And the reason for that is because initially you're doing a lot of stuff and your mind has to be actively engaged with your body. So your mind is working at body speed because a lot of the stuff is new and your body muscle memory is absent. Okay. But as and when you do these things lots of times, which you have to do, right? By the time it's week 6, you would have done this millions of times, right? So your mind cannot afford to be consciously engaged when you're walking, saying, am I in balance? Okay. So, all these membranes and things work automatically. So the autonomous system will take over at that point. And you'll find that going fast is faster, is better then, because then it'll be annoying, right? Right now, you're just feeling insecure, saying, can I do it? Can I get that fast? Can I that fast? That is insecure is much better, I think, right? Then when you get there and you start feeling annoyed that your body is not able to keep up with the the pace of your mind. Okay, and so these are tricks that you can learn as you're picking up, right? So like, so when my daughter was learning the piano, the teacher used to tell her to slow down all the time, slow down and learn the correct sequence first, because you can always pick up speed later, but accuracy has to come first, accuracy and then speed. Because if you do it wrong fast, then it's really hard to do it even wrong slow. Because even if you do it slow, the mistake is now becoming ingrained. So he used to say, and that I think was a very good lesson that was appreciated by all parties, right? So I think it's the same lesson in C++ also. These tricks are good to keep in mind, because when you want to go fast, you won't do fast wrong things, but you'll do the fast right things, and it'll give you the flexibility and freedom to do that. Okay, now what you want to do is change the size. The second line, saying line number 10, you're going to say after size off, after the word size off, you say size of an array, size of an array of 5 floats, right? And in fact, yeah, size, no, not there. That has got to be, what did we declare an array? We haven't declared an array yet. Oh, I see. We have to declare an array. So let's declare an array. After main, just hit enter and say float array, or some, give it a name. Float Zane's array, and then square bracket 5.
Float Zane's array.
Yeah, we'll call it whatever you want. You know.
I'll just call it array.
Yeah. Square bracket 5. And you got to have 5 in it.
That's the size.
Semicolon. Yeah, and then that is our array. We have not declared the array, and we're telling the compiler, give me memory locations, sufficient space in memory where I can store 5 floating point numbers. That's what that statement means. Yes. Now you know the parts of the statement. You can replicate it in different ways, right? You can change the name of the array. You can change the number of elements you want. You can say, give me a place in memory where I can store 50,000 floats, 50,000 doubles, right? Because a double is 8 bytes. Or you can say 50,000 characters, right? Char, right? 50,000 integers. So you can say all of those things.
Where do you sorry, Professor, where do you declare the name of the array?
There you go, array, ARRA1. That's the name.
Where's the variable name though? To like
array is a variable name. Yes, thank you. That's why I was actually hesitant for a moment when you changed it to the word array, right? Because array is the name of the variable. The Zane, you can call it Zane's array, right? Zane underscore array. I think that would be better.
Okay, yeah.
Okay, that's better, right? Because array sounds like a language word.
Yeah.
All right, hit enter there, just so that we separate the sections of the program, just like English essays, right? The first is the leading paragraph, okay, blank line. The leading paragraph just introduces the characters, right? The characters in display, the screenplay, right? That is your declaration statements, all of them in one place, right? And then blank line, and then your logic, okay? And your logic could have many acts. Your screenplay could have 5 acts, right? So act 1, act 2, act 3, and you have blank lines or intermissions between them. So your blank lines are so you can structure your program as though it is a small play, right? With appropriate lines, and that's because it's an artwork, right? Eventually you'll be reading things like this, okay? So float. All right, now what you want to do is size of Zane array in there. All right, now here, see, it's different. This is different in many ways from the previous statement. In fact, I also change the comment, right? You change the inside the quotes, say size of Zane array on this computer, size of Zane array on this computer. Now instead of there, size of on line 12, on line 12.
Yeah.
Thank you. Yeah. And then you need to change also the inside this quote, in the string inside the quote.
Here
on the next line 13.
Oh,
size of Zane, or in fact, float, you say float square bracket 5. Don't even have to change Zane. The float square bracket 5, which to readers would mean we're talking about in a size of 5 floating point numbers. Does that make sense, everybody? Yeah.
Mm-hmm.
Yeah.
All right. Let's put some blank lines there. Clean up things. Where you say on line 8, you say declare a native array. Triple click on the line and move it above the actual declaration, because Control X, Command X, 2 up arrows, and then your cursor will be where you need it to be. And now paste, Command V. All right, so you've declared the variable right there. So we're just moving comments around to make it more structured. Okay, this array in memory ought to, also that comment needs to go there, right? That comment. Yeah, and then obviously it's not 10 times 4, it's 5 times 4. So you need to fix that. Oh, well, okay. Now you lost the highlight. Right, triple click and move it again. Yeah. Oh, you went 4 instead of 3. There you go. That's another trick. Yeah, you discovered is 4 clicks. You can get the entire thing, not just the line. I think 4 clicks is the paragraph, not the entire. I don't know. You can just move that also above 7. No, it'll now. Yeah. So
that's just like muscle memory for me.
Yeah, that's right. Yeah, but once you get over that, you'll find it's really useful. What you need to focus on is just the insertion point, right? Then it's frees up. You don't have to look at the rest of the file. Your insertion point is always column 0.
Okay.
So you can just move your cursor, because if it's column 0, then you don't even have to worry about when do I need to stop, right? So you just keep hitting left arrow and forget about it. It will stop automatically when it hits the margin. So all of those things will be very useful. All right, now if you run it, we'll see what the size of the array is, right? 20 bytes, right? Now you know 4 times 5, 20. Yes. So that's really cool. And believe me, this is not the end of sizeof, okay? Because sizeof you will use in other contexts in programs to find out how many items are in an array, right? In fact, if I told you here is an array of floats and you didn't know how many floats there are, how would you find out? The way you find out is find the size of the array, divide by the size of float. That tells you that 20 divided by 5, 20 divided by 4 is 5. So therefore, you can infer that the array has 5 elements instead of being told that there are 5 elements. Does that make sense? Is that cool or not, right? If you didn't know the size of a native array, right? And it wasn't given to you like, like a memory address saying there's an array starting there. If there's a native array right in front of you and you didn't know how big it was, right? You can ask the compiler in your code saying, well, you know what, give me the size of the whole array. What is the array store? And one of the really important things about arrays is that arrays can only store homogeneous elements, right? Every element in the array has got to be exactly the same size. That is the only trick and only reason why arrays are so valuable, right? If you were given a bag of items and the items were different sizes, right? The first one was a float. The second item was a character. The third item was an integer, right? Maybe some really complex thing, the cout, right? The fifth item was a cout, right? Big object. So if I gave you that, it's a useless thing. How would you know? If I told you, give me the fourth item, how do you know where to go? You gotta go item by item and say, well, are you the person I need? Are you the person I need? Yes. However, if I told you, here is a bag, each item in this bag is exactly this big, right? 5 inches long. Yeah, so something like that. What is this, 5 bytes, right? So if I said this is an array, and this is each element in the array is 4 bytes, right? 4 bytes long. Then right? If I told you, give me the 100th element in this array, you don't have to walk the array saying, well, I don't have to take 100 steps to get to the 100th element, because I know I can just travel the hypotenuse. From here, I don't have to go like that and that. I can just go along the hypotenuse, bam, like that, because I know that the 100th element is exactly, what is it? 100 times 4? 400 has got to be at exactly 400 bytes away from the 0th element, because each element is 4 bytes long. Yes or no? Okay, so that is the only greatest advantage of arrays, right? And that is the only advantage, really, I think, for many. Well, let's just say greatest by far. And in fact, you can ask anyone, right? People using vectors, if they don't know, that is the reason a vector is valuable. They don't know how to use a vector, okay? Because once you know that, you'll know where to use your bread in your dish. Because otherwise, it's just like throwing your ingredients all over and hoping it'll work, right? And those dishes don't turn out to be very tasty, right? So, all right. So, is everybody okay with this? Now, what are the elements of this array? The first element has an index of 0. The second element has an index of 1. So, how many elements are there, and what are the what are the indices? So, it's 5 elements.
0 to 4.
0 to 4. Yeah. Okay. So, the last element is Zane array square bracket 4. Okay, that is the last element. Yes. Yes or no?
Yes.
Good. Thank you. Hey, Zane, you should not be the only one who's responding. Okay, just because Zane is typing, he shouldn't be the only one who's responsible to talk. Okay, everybody should respond. Right? Be interactive. This is a group discussion. I'm the only one talking. Right? So at the end of, I'm in fact, I'm the only one who's ever talked except Zane. Nobody else has talked in class. It's 9:15, right? It's more than an hour since class started. So everybody should be interactive and talking. Okay, all of you, right? All of you. I don't know. Fernando, Ali, Fernando. I don't know. It's your photo, or are you there? I think it's your photo because that hasn't changed at all. All right. Okay. So maybe I don't know if you're here. I can't even hear you. Okay. At least other people I can see.
I am here. I am here.
Okay.
Yeah, I am here.
All right. Good. So is everybody okay with this so far? Well, what are we talking about? So what we want to do is now let's on the next line, on line 14, let's say on line 14. In fact, change the return 5 to return 0, right? The return 5 was just to make a point, right? Just make it, that is your standard template, right? Return 0, right? So on line 14, hit enter and start a comment. No, let's create a blank line because we want to do something new, right? I want a blank line. Start a comment and say, let's fill up this array with 5 random floating numbers. No, where you started the comment. No. We need the blank line. We need the blank line above.
Oh, okay.
Right. Let's fill up the array with random floating point numbers. The array, the. Is everybody okay with this? Yeah.
Yeah.
All right. So we're going to use a while loop to fill up the array. Yeah, and the while loop is going to be while. Hey, let's use a for loop. Okay. You can try using a while loop if you want. Say for. So for, and then within parentheses say size t. And conventionally, don't use fancy names like, Q, X, Y, and all. Convention is I, J, K for these loops, right? So size t, I equals size underscore t, size underscore t, space. Did you compile already?
No, I don't know.
Someone must have compiled it. Or someone is running something, okay? Someone is doing something, not listening to class. Is someone running stuff?
Sorry, that was me.
Hey,
I
Ashwa, just
was-
listen now, okay? And you
Okay.
can play around later. You can play around in your own time too, right? After class, you can play around. All right, good. Size t, I equals 0. And then semicolon. These are 3 different statements. We're just putting on the same line for readability, okay? I equals, no closing parentheses, just semicolon. That's the first statement, right? Next is going to be the condition. So you say I less than 5. Yeah, I plus plus, and sorry, a semicolon again. I plus plus. This is your standard for loop format, okay? And then open squiggly, open squiggly. No, you need the closing parentheses, parentheses, and then open squiggly. All right, so that's inside the body. We're going to create a random number and put it in the correct box, okay? So put a comment there saying make a random number first. Make a random number, okay? Yeah. Okay. On the next line, you say float. Float. Let's say x. Float x equals. You're going to generate a random number. Okay. Say ran, and then open close. Right, and then space after that. Not there. Yeah, there. Space, and then you're going to divide by. You're going to generate a random number and divide it by the maximum possible random number that function can give you. That was guaranteed to give you a number between 0 and 1. Yes or no?
Yeah.
Okay. All right. But what is this maximum number that RAND can give you? That, in fact, is defined in a library as a constant, right? We're going to pull that and use a constant. And that constant is called RAND underscore max, all uppercase, right? RAND. Oh, it's got to be all uppercase.
Oh.
Underscore max.
Also uppercase?
Uppercase, yeah, semicolon. Now on the next line, you can say, put this number in the correct bin, right? Put this number in the correct bin on a comment, right? Put this number in the correct bin. Technically, you can do all of this in one line and you don't even need squigglies, right? But we're doing it like this just so it will be easier for you, right? Put this number in the correct bin. On the next line, you say Zane array, square bracket I, Zane array, square bracket I. No, I think it's Zane underscore, yeah.
Yeah.
Oh, it actually autocompletes. Hey, I think it autocompletes. You may be able to hit tab and get Zane array, right? If you hit Z, if you just type Z and then hit tab, it may give you Zane array in here. I think. No, you have to type Z. I think the key up. Hit enter.
Yeah.
Cool. All right. Good. So I and then space equals. So space equals X. Now what we want to, is everybody okay so far? We want to do one more. Like 2 seconds, exactly the same, but we're going to print it out instead of actually, we're going to print out the contents of the array. Yes? Is there, that shouldn't take a lot of time. What we're going to do is now this choreograph, this little dance, Zain, go to line 15, triple click on the line, but don't let go of the mouse. Triple click and hold it down. Right now, while you're holding it down, drag all the way to line 21. No, you let go and then you're dragging. Right? You have to triple click, don't let go, and then drag. No, triple click and then drag. Triple click and then drag. No, oh, maybe Kylie did this and it didn't work then and even then. Okay, you need to copy everything from line 15 to line 21. But you need the indentation also. But then never mind. Okay, that's
I think it was working.
It was working. That's fine.
Yeah.
Okay.
All right, okay, now copy that and then paste the whole block again on line 23, just before the return. You want one more block like that. Right? And move the return a couple of lines down. All right, now the comment on line 23, let's change it, right? Let's print out the contents of the of Zain array. Let's print out the contents of Zain array. We're putting all these comments there because some of you who aren't able to attend the class, you can just watch the video without having to listen to me, right? You can even fast forward it and watch it at actually YouTube lets you watch it at 2x speed, right? So, well, you should be also thinking about what Zain is typing, right? At 2x speed, you won't be able to think about it. So, but you should be able to watch what he's typing and look at the comments, or you can pause at the right times and read the comments. All right, so here, instead of Zain array equals X, and also get rid of float and get rid of all the inside guys, right? Line 25 to line 28, we don't need, right? Get rid of all that. Yeah, get rid of that, and we'll just do a C out there. C out, and then and within quotes, we're going to do this complex stitching together, right? Within quotes, you say Zain underscore array square bracket, just square bracket, okay? Just square bracket, nothing else. Oh, no, not close, right? Just square bracket. No, one square bracket, open square bracket.
Oh, okay.
Okay, now go outside of the quote and left shift your I. All right, now left shift another string. All right, open quote. Right, now close square bracket right there after the I. All right, okay, space equals. Now go outside of the quote and say Zain underscore array square bracket I to the compiler. And then end L. All right, now we did a couple of things on this line, but you will do a lot of this in your debugging, okay? When you go to advanced quests or even when you're coding on your own. But this is a trick, right? When you do cout, very rarely, well, sometimes, maybe not rarely, okay? It's some meaning, very frequently, you may have to do something like this, right? Where you have to surface multiple values and you want to have arrays and contents of arrays. This is what you do, right? Many times when you're working with arrays and algorithms and you want to see what the array contains or what the last 10 elements of the array are, this is what you do, right? So you can basically have those 3 lines in your memory. That's saying, well, when you're debugging something complex, you can put it in there. Why is it all? Oh, I see. Go back to the previous thing, or line 8, I think, line 8. Right. Where you do the division. Right? You know why everything is 0? All right. Before I fix this, I want to give you a chance. Right? Someone else give me a wrong answer. Okay. I want the wrong answer. So someone give me a wrong answer for why you're getting all zeros. We shouldn't get all zeros, right? We should get all floating point numbers. Yes or no? We should get all floating point numbers. Yes.
Yeah.
So why are we getting all zeros?
Because we're setting the array to 0 here, and it's.
No, we're not setting the array to 0. Why are we setting the array to 0?
I mean the contents of the.
No, we're not setting the contents of the array to 0. We're just printing out the contents. On line 25, we're just printing out. Yes.
Yeah. We're.
All right. How about this? Okay. Anyone who answers this can actually email me for some kind of credit. Okay.
Is rand max 0?
No, rand max is not 0. Rand max is, I think, 32,000. In fact, go up to the first line and print rand max, see out rand max, and we'll see what rand max is, right? Just inside of main, we'll delete it, right? Yeah, just do a C out of rand max, C out rand max, and end L, and run it. We'll see what rand max is. And then delete that line. I think it's 32,000 something. What is it? Oh, it's some big number. Okay, it's some big number. It's like actually a 4-byte. So rand on this computer, rand returns a 4-byte number. Okay, you cannot depend on that. Okay, most implementations of rand out there only return 2 bytes. The biggest random you can get is 32,767. And this is unconventional because if someone wants a number that big, they may end up using a better distribution. Well, maybe they'd use this. I don't know. Maybe they've changed the algorithm. Maybe this is the right thing to do. That's good. That's good. Spammers.
Is rand divided by rand max? Is that like significantly close to 0? Is that why?
No, but rand. So if you, I'm sure if rand max is that big number, your randoms also will be big numbers. Okay. After you print your rand max, just print a random number on the first line. On the first line, I bet it'll be a huge number, right? I bet even your random will be huge. Just print some random number. Rand. Just call rand. Right there. Rand. Open close. Yeah. Endo. I bet you'll get a huge number here, right? It won't be under 32,000. You can increase the size of the console, man. So yeah, just increase that. Yeah. See, even your number randoms are big. So your randoms are actually good. Yeah, on this computer, in this architecture, they're giving you big random numbers. Like, you know, on your Xcode, if you have a Mac, there's a function called arc for rand or something like that. That is what I used to use when I wanted big uniform random numbers, right? But apparently even rand does big numbers now. But I can rely on that until it becomes more standard and mainstream. But okay, so we're getting these numbers. Why are we getting 0? This is actually a useful question, right? I'm happy we started coding this because all of this actually solidifies not just your arrays and looping and statements,
Zane,
but
can
also
you
solidifies.
put down the console a little bit?
Thanks.
Thank
Yeah, I was about to ask also. Where are we getting 0? Why is X always 0?
Because the scope of the array is like, we only change the values in the scope of the first for loop.
So the scope of the array is, I think the array is at a main level. I think, array is there. Array is in scope. Array one, Zane array will not die until main exits because main array is created as soon as main is entered. So the array is in scope. Take another stab. You know, I want more wrong answers, right? The more wrong answers we have, the better grounded our right answers will also be. And I don't mind waiting, okay? But you think about it and come up with the right answer. It's going to be useful.
So is rand and rand max are both, they're just integers?
Yes, thank you, Zane. Yeah.
Is it because we're casting a float? X is a float and you're dividing 2 integers?
Right, that is exactly the reason. Does everybody, I'll explain it a bit more, but that is the reason. Okay, Zane hit the nail on the head. Okay, the reason here is, and I think I've mentioned this before 3 times in previous classes, to you guys, I think, is that integer division, right? In our mind, we think that slash basically just division, right? And I can give it 2 numbers and it'll divide. But it does a lot of clever things. It actually does. It makes a decision. Am I supposed to use this procedure to divide or that procedure to divide? 2 different things if you want to divide floats or integers. Yes, 2 different algorithms. So if you give it 2 integers, it's going to do integer division because it thinks that guy wants integer division. I'm going to do integer division. So integer division means any floating point result will be discarded. Right? And this is guaranteed to be less than 1 because your rand is guaranteed to be less than max rand because max rand is the maximum possible number that can come out of this. So this has got to be, so this number has got to be between 0 and 1. Yeah. It's a fraction and the entire number will be discarded. And so you end up with 0. So that is the reasoning. So that is why this is a bug that could bite even experienced programmers when they have forgotten the type, right? You have to be like super duper careful because you look at this code, easy, okay? We managed to identify that. But later on, you may have some complex program, right? And you're looking at some code and everything looks, if you look at that code, everything looks perfect, right? It's very hard to spot the error. Because here, we spotted it because he has the word float before the X. But let's assume that float was declared, X was declared up there and already used and you're doing the division and assigning here. Now that at that point, you're basically sunk, right? You've lost 4 or 5 hours of work right? If you're not careful, because you don't have any type information on that line. Your eye, when you're scanning your code, you're looking for high-level problems. You will miss that, right? Some subtle calculation, which is supposed to return a value, has lost the floating point value, which is critical for downstream calculations. And your algorithm doesn't work. And that is itself not a problem, okay? If your algorithm is a simple algorithm, right? Because simple algorithms have one or two ways in which they can fail. If it doesn't work, you can say, okay, I can check these two ways, right? But you will be working, especially if you're a professional, you'll be working on algorithms that can fail in 5 trillion ways. And many of them are actually intelligent, complex ways, right? So when you're looking at your own algorithm, and also you're confident because you've been programming for a long time, essentially, right? And you're confident of yourself, you're not going to suspect something silly like this. Yes?
Mm-hmm.
So what are the chances that you'll find the bug at that time? If you're not careful, if you've not developed the care and eye for detail at this level. Yeah, so those are the people who waste a lot of time programming downstream, doing stuff that they don't have to do because they were not careful with their data types, and they get 0 and they can't notice a 0. And in fact, here today, you got to be like not even twice as careful, n times as careful, because these numbers eventually will even filter. These numbers becoming 0 and non-zero may even not even be seen by you. Maybe this is part of a machine learning pipeline where it's generating numbers, right? And it's generating zeros. And zeros could basically flip an example from positive to negative. Yes?
Mm-hmm.
And so your entire machine learning system could be going wrong. But when you're thinking about your architecture from a machine learning point of view, you cannot afford to be thinking about it at the byte level. So you're going to be thinking, well, this is not working. Is it because I included data from that suspect source? Is this because I included data, or is it because there's a million reasons that are valid that will, seem like valid use of your time? And yeah, so that is why this is very important. So to fix this, all you have to do is, because we know it's float and x and so on, just take the word double in front of rand, okay, within parentheses. You're going to say, so, and the reason that happened is because from our precedence rules, PEMDAS, we know that the equals operator has lower precedence than the division operator. That's something you have to pick up, I think, right? Or learn. The equals operator is lower precedence, which means if there's a line that has equals and plus and division and multiplication, it's going to use the PEMDAS rule and say, well, division is the highest priority. Let me do that first. Okay. So when it does the division, it doesn't know it's going to be assigned to a float because it hasn't encountered the equals operator. Yes. Because it has to do the high priority stuff first. Yes or no?
Yeah.
Yeah.
Okay, so it's going to the
That makes
division in
sense.
integer space, and then it encounters the equals and says, oh, it's a float, and I've got a 0 value. Let me convert the 0 to a float, and it's saying 0.0. All right, so this is a convoluted but actually simple reason that goes on behind the scenes for us seeing the 0 on screen, which could actually turn out to be a really nasty bug downstream had we not encountered it now and basically just ingrained it into our memory, saying, well, that could have happened later on. Thankfully, I found it now. Yes. Yes or no?
Mm-hmm.
Okay, so it's a serious bug, and it's not just to do with C++. Okay, you could be a Python programmer, you could be programming in some other language. I know people have exactly the same problem, right? Even experienced programmers, and that's why it's so important to nail these down. All right,
Wait, this might be a dumb question.
No, there are no dumb questions. Okay, as far as I'm concerned, there are absolutely no dumb questions.
Why do you use double and not float?
Sorry, you can tell me.
Why do you use double and not float?
You can use double. You can use float also. Just
It
use
says
float.
like float x equals double rand, right? Can you do
Yeah.
float rand?
What will happen there? I'm sorry, I meant to say float. Sorry. Thanks, Sean. Actually, let's do the cast also in a slightly different way. Turn the double into a float. Turn the double into a float. And then put the float within parentheses, right? And not the rand and all that stuff, right? Float. And then you don't need a parentheses around rand. Yeah, okay. I put a space there, space between the float and the rand. Okay, that is one of the conventions in which we cast. That says, all right, so again, let's follow this reasoning here. And many people don't follow that, okay? And I'm saying other programmers, what's going on there is it says, well, you know what? Division is the highest priority. So I'm going to do the division, okay? However, if you run it now, right? If you run it now, you'll get the right answer. Run it now, you'll get floating point numbers for the 5 guys. Yes? 5? There should be 5. Why don't we get 3, 4? 0, 1, 2, 3, 4? No. Go. Where's your loop? I0, I less than 5, CO. That should have printed 5 of those, right? Should have printed 5 numbers. Run again.
There you go.
All right, okay. So something happened last time. All right, so all right, now it works, right? So let's go back to that line now. So I'll tell you why it worked, okay? Even though division is high priority for the compiler, if you read the documentation, you will find that typecasting is even higher priority than division, okay? It's a peck order. Typecasting something is even higher in priority than division. Okay, how would you know that unless you read the documentation, right? So it does the typecasting of the whatever rand return to a double first or float, and then did the division. But because it's dividing a float, it cannot afford to use integer division. It does the division in float space. Does that make sense?
Yeah.
All right. Now, Sean's point is that, well, it wasn't a float. We did a double and it still worked. And the reason for that is because the algorithm for float division and double division is the same. And if you use a float and double interchangeably, the compiler is intelligent enough to do the conversion itself.
Okay.
Does that answer your question?
Kind of. So there's no difference
Change it to
between the
double, it'll
float.
still work. Change the float to a double, it'll still work. You can double click, by the way, right? Backspace means you got to get it 5 times and also, stay engaged. Double click, you don't have to stay engaged, right? So double also works, right? Double and float use the same algorithm for division, but integer uses a different algorithm for division. Is that a better more helpful way of thinking about it?
Yeah.
Okay, so you can use double and float interchangeably, but you have to be mindful that a double uses twice the amount of storage a float does, right? If you use double, everything will be 8, right? 8 bytes, 8 times 5 is 40 bytes, right? In fact, if you change the array, Zane array to double, you'll see everything is changed Zane array to, in fact, there was a comment we need to fix, right? Oh, 5 times 4, we fixed that, okay. So if you change that, you'll see that, also size of float, change size of float to size of double. And also on the next line, you have size of float 5. You just change that to size of float 5, change that to double. Now you'll see everything is 8. Not there. Not the other one. Double click. Don't backspace, double click. Get in the habit of double click, okay? Double click, triple click, those are all useful reflexes. Yeah, okay. Yeah, all right, double fine. I think that's enough, right? If you run it, you'll get size of float on this machine. Where is the size of float on this machine? I thought we changed the size as a double.
Because I didn't edit that part.
But double click. No. All right, okay. All right, great.
It's the muscle memory.
Like, I know. Yeah, that's why I'm reminding you. All right, good. There you go. Okay, size of double is 8. Yeah, okay, and now everything is times 8 now. For 5 times 8 is 40. Does that make sense? Was this a useful exercise? I know. What time is it now? Maybe we wouldn't have a chance. Well, we've got 10 minutes for you guys to play around, but this is based, and I'll show you how to use a vector. Okay, so this is a native array, and then the properties of arrays. It has to be the same item. And then why it's advantageous, because you can multiply and go directly there along the hypotenuse instead of going like that and that. Does it all make sense?
I have a quick question. Can
Ali,
you?
yes.
I'm confused what you're referring to when you say typecasting.
Oh, all right, good. Thank you, Ali, for asking. Typecasting means, right, we're telling the compiler. Typecasting is a signal to the compiler. It's not going through to the machine code, right? It's just a signal to the compiler saying, hey, compiler, I'm going to calculate something here in integer space just because it's easy, but at the end, I want it to be a double, because on this side, right, or something, because I'm going to do further calculations, I'm turning it into a double. So that is called casting, right? Casting means, what does the English word casting mean? Cast means take something and cast it there, push it there, right? So typecasting is take something that is of a different type and cast it to this type, right? Take a dog and make it a cat. Right? Take and push it. So a float is only 4 bytes. If you typecast it, tell the compiler, force it to, it's not a float, it is a double. He'll say, oh, wow, you know what, all right, it's 4 bytes. I'll just stretch it to 8 bytes and put the float in there. That's typecasting.
Okay, I think I understand. Thank you.
Everybody okay with this so far?
Wait, can you explain it one more time? I'm still a little
confused. Typecasting is basically a signal to the compiler, right? It's basically a signal to the compiler that says, I've done something in one kind of space, integer space, right? but I want to do more stuff, but I don't want it to be integer anymore. I want it to turn into a double. So turn it into a double for me. So that is called typecasting. It doesn't have to be a double. Maybe you create an object called Sean's object, right? Later on. You create your own type.
Yeah.
All right. So yeah, and so isometric triangle. All right. So that's a hypothetical data type you've created in the future, right? And it has a number of interesting methods on it. And so I can instantiate, just like you say, let's have this flight of fancy here and do this, right? It's going to be fictional and it's going to be fun. Okay. Hey, Zane, right? Online, and this is not related right now to what you're doing in arrays, but this is something that you would probably do in like 5 classes from now. So it's going to be useful. Okay. And it's going to be a fictional story here. And not it's fictional, right? So on line, where's your cursor?
Here.
All right. Hit enter there. Hit enter there. All right. Suppose in the future, Sean went ahead and majored in, let's say, some kind of topological theory, right? And came up with a new kind of object, right? Which can be modeled computationally. And it's called the isometric triangle. Okay. So he went ahead and created a library of calls. He created the data structure and a library of calls that you can issue on the object, just like vector. We're going to use a vector, but he has created this isometric thing. So this is how you would do it. Go right to the top. Go right to the top. Okay, under hash include IOStream. All right, enter. Hash include. All right, open bracket. Or you say single quote, double quote, right? Let's not say open double quote. And here you're going to say isomatsu.h, isomatsu.h, isomatsu.h. Okay, and then put a blank line after that, right?
Oh, blank line or space?
Blank line. Oh, and spelling is wrong. It's not Matsu, it's M-A-T.
Oh.
M-A-T. Right, on the previous line, on line 2, hit enter. Right, so two lines to start a comment. Right, use isometric use isometric triangles to manipulate to manipulate objects in this project. Or something like that. It's a lame ass comment, right? But basically that's what we're doing. On the next line, this is what programmers would do, right? And maybe you're going to do this, right? For further detail, on the next line, put a comment there saying, right? For more detail, see, and then you're going to provide, an AMA style citation here. You're going to say isometsu and isometsu. No, uppercase I, right? Because now there's a name, isometsu, and A and D, and TAW, T-H-A-W. I'm just pulling some names here out of thin air. T-H-A-W, right? And then space, open parentheses. I think this is how it goes. This is a long time since I've done these citations, right? Open parentheses, open parentheses. I don't know. Let's say 5 years from now, 2026. Okay, all right. So in the future, let's say Ali and isometsu collaborated on a paper, created a brand new data structure. This is going to be like super duper useful for solving complex topological problems. Okay, and then they created a data structure. And then further down, when you on this line, go to line 25 or something. Right, and this is not going to compile, by the way, okay, because we're using these fictional things. Okay, go to line 27. Go to line 27. Oh no, go to line 33 before the return. Right, and say hit enter, and put 2 comments there. Yeah, open a comment saying now instantiate an isometsu object. Now instantiate an isometsu object. Yeah, it's fine. Well, what you type was fine. Instantiate an isometsu object. Right, on the next line you say isometsu space. It has to be capital I because that's the object that's you isometsu space Zane underscore triangle. Okay, and semicolon. All right, now that would basically fire up a call in Sean's library, right? That Ali and Sean have written. It's a function, and it's going to create this object for you and give it to you. Bam, like that. Now you're going to use it. All right. On the next line, you're going to say calculate the vector projection using calculate a projection using this triangle. All right. Okay, or you say calculate our projection, right? So say not a projection, our projection. And also above on line 33, hit a comment saying ... saying there's a whole lot of magic that's happened there. This is not like continuing there, right? Just put a ... there. And also put a blank line above that so that this is all fictional stuff, right? All right, so on the next line, you're gonna say, on line 38, you're gonna say int n faces equals,
Sorry, you're
yeah, number of faces. So essentially, you have a triangle and you're giving it a floating point vector and saying calculate this hypothetical object in space using this triangle and tell me how many faces it's going to have, so that I know if it's a regular object, I know it's the result of this calculation is going to be this polyhedron with or something like that. All right. So I don't know. So I'm just this is just theory. It's a story like Game of Thrones, right? So equals Zane underscore triangle dot. All right, calculate num faces, calculate underscore num faces, and then pass it Zane array. No, you got to pass it Zane array as a parameter, right? And change the c to a lowercase c, and then we'll put a comment there, and then you have to pass the array as a Zane array as a parameter. We're doing a lot of stuff here, which is not going to work, but essentially this is an example of this is how you create objects and use it. Okay. And all right, no, that's it, right? And oh yeah, we'll put one more comment there. We'll say invoke a method, invoke our required method on this object using our array, something like that. All right. Now this is essentially what you're going to be doing from quest 6 onwards. You're going to be creating objects, okay, and invoking methods on those objects. Does it make sense? Okay. And in quest 7, what you're going to do is you're going to be creating lots of objects. And you're going to put all of those objects in an array. And then you're going to be invoking methods on these objects, but you don't have the name of the object, but you're going to refer to the object as Zane under square bracket I dot my method, Zane square bracket I plus 1 dot another method. So you're going to be invoking methods on objects that are stored in arrays. All right. So now you're doing all these things, but very soon, in just 2 weeks, you're going to be doing something that it requires you to do all of this in one sitting. Okay, so you're going to be using objects, methods, functions, while loops, branching statements, and invocation of methods on these objects. All of that has to be like second nature to you by quest 6. And the thing is, you don't have to say, oh my gosh, there's no way I can pass 2A. There have been students like that. And there have also been students who said, there's no way I can pass this class. I can't even get past the first 2 quests. And then I asked them, after they finished quest 9, the same people, all right, I asked them, well, you know what? You said this 7 weeks ago. You said this. Can you say that again? They say, there's no way I could have said that 7 weeks ago, right? Because you will see in your own self, you will see that, well, you know what? I thought this was impossible. It's actually not impossible at all. In fact, it's like super duper easy. Okay. So the first step is actually seeing how difficult it is. I don't know if you see it as difficult, but very soon you're going to be using all of that. Like, second nature. You're going to be just doing that. If you're bored, you're going to be doing that like that. Okay. So because this is basically what you need. Right? Once you have all this, this is a basic block. Okay. Basic building blocks. Once you have this, we can start looking at solving problems. That's all. Really. Okay. Up till now, we've covered all, vectors. We haven't talked about vectors. In fact, we'll talk about vectors on Thursday, right? And we'll all, we'll take this project. Hey, Zane, we don't have to save this, right? On Thursday, we'll do exactly the same thing. But instead, we're not going to talk about native arrays. In fact, we spent the entire class today talking about native arrays and examples. On Thursday, we'll start with vectors, okay? And we'll create some fun problem I'll think of, right? I actually had an idea for a fun problem today. I forgot, but maybe it'll come back to me. Or you guys can think up too, right? And then we'll have this, right? All of these people, each one with their own file, and type in a vector, okay? Now you know what a vector is. A vector basically has an array inside of it. And when you say Zane array is a vector, and you can say Zane array of 2, it's going to go to the, that inside vector, all right? Inside array. although you're talking to a vector. But the reason we use a vector is because it does a lot of nice things for us. Okay, your vector, there's something called a stack and a heap, and a vector is on a heap, which is more flexible than a stack. Okay, so vector takes care of your array in a different way than you taking care of the array yourself. So those things are available, and I'll show you those really cool things next class. Okay, on Thursday, it'll be a lot of fun. Believe me, right? So I think, I don't know, maybe some of you are already programmers, okay? So that's the thing I told my 2B students too, right? We have a huge mix. We have people that are already programmers who just come to pick up C++ syntax, right? And there's people, even high schoolers who want to learn about programming and trying to venture into C++. So we have a spectrum, and everyone has to help each other. Otherwise, there's no way this class can be harmonious, right? It's not like a UC, for example, where the students are already filtered, and then we can take liberties and say, we're just going to go at the speed. Everybody better catch up, because there you don't have that, wide, distribution. So here we have to make sure that we can't drive as fast as we are able to. We always have to slow down and say, is everybody on board? Because, we don't want to leave people around. And also, I told you this too before, right? I want all of you to complete the Bleak Quest. Whether you pass, I don't care, right? I want you to get all the way to Blue 9, right? And I'm going to give you credit for all of these quests in green. If you go on to do 2B, you already get credit. Coming into 2B, you get credit, right? So I want, because that's the way to become a great programmer, right? And do these really cool things. Is that okay? Does it make sense?
Yeah.
Was this useful? It's not going to compile, by the way. It's past class time, so I understand. I know Kylie has to run. Okay, you're close to your class. Hopefully, you're in the PS, right? So it's close to end of class, so we won't belabor any more issues unless you want to. I'm willing to stick around. But other than that, if you have any questions, just let me know. I think it's a great class. You're all interacting and feeling free to ask, right? And you have to remember there are no dumb questions in my class, okay? The only bad questions in my class are mean questions, okay? Even on Reddit. And I've made that known. I've made that known to students who have complained. And I believe there is a campaign actively happening on campus at Foothill right now, because there's a 2B student who's not happy with public lectures and public forums and wants to take everything private. And yeah, I know there are people that don't like this particular way of doing things, but I'm happy to work with anyone for whom this doesn't work. Just send me an email saying it doesn't work for me. Can we do a one-on-one separately where you can establish my knowledge using questions, right? Or have a discussion and give me some problems to work on while you watch, right? I'm happy to do that. So that would be a much better way for you to ask. Say that my learning style is not suited to this class, than to say this learning style is discriminatory, so it should not be offered to anyone. Is that a reasonable way to do it? Yeah. So
yeah.
Yeah. So if you don't like the learning style, please don't complain, and get other students to join you and boycott class and things like that, or complain, because it doesn't do anyone good. Not even yourself, because really, that's what I told my 2B students, right? You can spend hours and hours trying to construct elaborate arguments saying this is wrong, you shouldn't be doing that, right? But I can always come up with easily perfect workarounds that are absolutely legal, because I'm doing the right thing. I'm doing the thing that I think is important to you, and I can come up with ways in which I can still do the material exactly the same way, grade things the same way. So it's a waste of time on the student's part. You're here in college to learn, okay? Don't waste your time lobbying in class, right? So these 4 years or 2 years or whatever it is you're here for, make use of that to learn, and you'll thank yourself for it later on, okay? Because lobbying you'll forget, learning you'll not forget.
Hi, Professor. Right. Oh, sorry.
Yeah.
I want to ask a stupid question. For the line 39.
On Zane's code? In Zane's code?
Yeah.
Yeah.
Can you go to line 39?
Which line?
39.
Yeah.
Here, numbers of faces. I feel a little confused about this line. If it is a triangle, what does it mean?
Okay. All right. So yeah, June, I understand. Okay, so let's change the name. I just call it triangle. All right. Zane, let's call it, I don't know, I don't know what Sean and Ali are going to come up with, really. I just said it was a triangle. All right. So call it, yeah, call it projections, right? So call it, instead of triangle, call it, yeah, int projections equals calculate number of dimensions or something like that, right? Calculate number of dimensions. Instead of faces, say dimensions. And I think instantiate an isometric projection, right? Instantiate an isometric projection on 35 and change, yeah, Zane triangle to Zane projection. All right, is that better?
Yes, thank you. So for the input, there is then array. There is 5 numbers. So the how should I understand the input is the array?
Oh, I see. All right, yeah, all right. Okay, so June is confused because the questions she's asking pertain to stuff that we're going to talk about in 2 weeks. Okay, hey June, you're perfectly fine. Okay, is it okay with you to just hold on to this question for 2 more weeks? Here, what I'm trying to show here is simply in the future you may be doing something like this, right? And in 2 weeks you'll know what that is. Right now, it's just a fancy. It's not going to compile. The compiler will complain. If Zane hits run now, it will just complain and say, "Hey, I can't do it." Right. So it's just a fictional thing. I just wrote something like out of imagination. Right. It's not going to run.
Oh, okay.
Right. Yeah. There's no isometric.h. Sean and Ali haven't even become research collaborators yet. So there's nothing like that. Does that make sense?
Yeah. Oh, okay. Thank you.
You should feel free to ask, okay, June? You can also ask in Reddit, okay? Just ask. It doesn't, see, lots of questions in the Reddit in broken English too. Who cares, right? Even if it's in a different language, Reddit has translators, I think. Automatically it'll translate. You can even ask questions in Mandarin, I think. On Reddit.
It's okay.
It's totally okay. Ask in Mandarin. Right, I think if I'm not mistaken, Reddit has a bot which will translate that using Google Translate.
Thank you. It's okay. I think.
Yeah.
I got it. Thank you.
No, but I'm saying something else, right? If it's something else, you should feel free. You should feel free, right? Anyone ask a question in Mandarin, Swahili, whatever language you want, just ask like that. If you have a keyboard, if you can type it into Reddit, right? Do it, right? Our bots will pick it up and translate it for you.
Thank you. I want to practice English, but
okay.
I'm just afraid my English was the other's time and make other confused.
Oh, totally. Yeah. In that case, go ahead, do it. And in fact, what we'll do is anyone who sees your question in the Reddit forum, if you want, we can send you a private message outside of Reddit, right? Saying this question can also be, a better way of asking this question in English would be this. That'll help you, right?
Yeah. Okay. Thank you.
All right. So just go ahead and ask. And then if we notice something, we'll just send you a private message, right? It won't be on Reddit. It'll be a private message saying, hey, you can edit the post. And this would be a better way of asking the same question. And that you can use that to say, hey, that's really cool. Next time I ask a question, I can ask like this. That'll help you, right?
Yes. Thank you so much.
Yeah. And everybody, not just June. Okay.
Yeah. And also, like, we don't think that you're wasting like anybody's time. Like,
all right, okay.
About that, right?
Thank you.
Yeah, we appreciate the questions. Yeah.
Thanks. So I'm super duper, psyched by this class. I like all of you guys. You're all invested in it, interested in it, trying interesting things out. Okay, so I think you'll all become great guys. Doing really cool stuff. As long as you keep applying yourself and don't get distracted or tempted into some dead-end path, right? Just gives you immediate low-hanging fruit fun, but you don't remember any of it later on. And so if you don't go there, I can see that all of you have this really brilliant spark in you, right? It will just lead you. Just follow the spark. It will lead you to great success. Right. Yeah.
Quick question. For here, do we, what is the size_t?
All right. Good question. All right. In fact, there is there's a video in which we have talked only about that. Size t is basically a type, right? Size t is a type, which is aliased, right? Which is translated by the compiler into unsigned long numbers. So it is a 4-byte unsigned number. So it goes from 0 to 2 to the 32, 0 to 4 million. That is a max size t.
Okay.
So it is a data type, just like integer and float. It is an unsigned integer, unsigned long integer. It is
Okay.
just another type.
So it's saying I is of type size underscore t, and we're
Yes,
setting
it is a
it.
size type, meaning it is going to be an unsigned int. You
Okay.
can change size t. Change size t into int, it'll still work.
Yeah.
It'll still work, right? We run it. Oh, it won't work because of that thing. Yeah. But size t is typically what we use for I and things like anything that is size related, because any time we are using a quantity or a variable that we know for sure to not be negative. Yes. So this is the beauty of computer scientists, especially, C++ programmers, is if you're using a quantity, if you have a variable and you know for sure that it is never going to be negative. Okay, you're only dealing with positive quantities. What is an example? Example of something that is never going to be negative? Size.
Size.
Right? Size is something that can never be negative, right? So, well, at least not in the universes that we're used to. So we say, this is the beauty of computer scientists. We say, you know what? If size is never going to be negative, and my integer is going to be 4 bytes long, why am I going to lose that 1 bit in every integer? Right? Because if I'm using a signed quantity, I'm losing that signed bit. I'm losing that MSB. Why waste 1 bit? It's only 1 bit. Think about it, right? Today we have phones in which we have, 128 trillion transistors, 128 trillion switches in one phone. And still, as a computer scientist, we are worried that if we use int instead of size t, we're losing 1 bit out of 8 bits, or 1 bit out of 32 bits. 1 bit out of 32 bits is lost for sign information, which we're not going to use. Yes. Because size we know for sure. So that is the beauty of scientists, computer scientists. We say anything we know that we can bring to bear to give us an advantage, we use it. So we say, why use an integer and waste a bit? We'll use a size t. We can use the entire 32 bits. Does that make sense?
Yeah, that makes sense.
So that is what size t is, right? Whenever you know that something is never going to be negative, just use size t. So you get the entire 32 bits instead of just 31 bits. Does it make sense? All right, good. Anyway, thanks. I'm taking up too much of your time, and I'm sorry I didn't give you any chance to code today, but I promise on Thursday, we'll just code a lot, okay? We'll start coding. Hopefully someone other than Zane. Zane's done such a great job today, typing ahead also sometimes, right? And also anticipating what needs to get done and fixing comments and styling. You don't have to do all that, right? Just volunteer to type, just like Zane did today. Not Zane, Keenan, or Ashan, someone who hasn't done it before. Doesn't matter if you're uncomfortable or you're going to do it slow. Who cares? Okay, we'll just go at your speed. So we'll just go. We have a lot of time. So someone other than that will start coding with vectors. It will set up a problem, and then that problem will be such that you can just take a copy of that, and it'll trigger like 100 million ideas in your head. Okay, you can create your own one similar to that, not the same, right? And then we have lots of files, and then we say, hopefully this time 9:30 on Thursday, we'll say, okay, everybody's done. We'll go one by one, run them all, okay, and see what we get. Is that okay?
Professor?
Yeah.
Professor, I have one question.
Sure. Yes.
So like I completed quest 2 with all the trophies, but then it didn't give me the code for the next quest. Like, why is that?
I don't know. It must be there. Okay, you got to check in the Reddit. Check in the Reddit, ask. And people can give you the answer without having to give away the. So don't waste time here. Okay, ask in the Reddit, because other people are also probably having the same question.
Okay,
Professor, I also have a question about quest 2. Also, I think it might be part of one of your submissions, because for me it said it wouldn't accept it, or it wouldn't give me the code because one of them was not like close enough.
No, but eventually you got it right?
I'm still working on it actually.
Yeah, that's okay. That's okay.
So for Limerick, I'm getting back 81, but I'm getting back like 81 over and over again instead of the other numbers in the series.
Oh, so there's a bug. There's a bug. Okay, so
Yeah,
you need to.
I need to figure something
That's a
out.
great question for the forum. Okay, someone would say, hey, maybe that's why it's going on, and maybe that's exactly what's going on to someone else too.
Professor.
Can you ask, Kenan? Can you ask in the forum?
Yeah, I'll post something.
Professor,
Yeah, Zain.
This is a general question. I think this may be kind of what Ashwath was asking about. Is like, so when we complete a quest, if you
Mhm.
want to, you know, like usually like some people complete a quest and they don't initially move on to the next quest. How do you like regain the code, because the test results from the previous test aren't saved?
No, the results are saved. I have your, I always have all your code submitted, and I usually base my scoring on the most recent submission, successful
Right.
submission.
Right. I'm saying like, how can we see it though when we're when
Oh,
we
you submit the code, right? You have your code in your IDE.
Right. So do we just have to resubmit to see the question?
Yeah, you can resubmit any number of times. Yeah, or you
Okay.
can just take a snapshot of the /Q page if you want.
Oh yeah. Okay, that's probably
Just go to
good.
/Q and enter a student ID. It'll tell you all the quests you've done.
And does it show in each quest the code?
How many trophies you got?
Or does it show to the key to the next quest in the trophies?
It does show. No, not to the next one. The next one will just come in when you're actually questing. You get the next one.
Okay, so to access, we have to resubmit then.
To access, you need, yeah, or you need to have remembered what the password was.
Or just save it. Okay.
Yeah, I just take a
remember.
picture every time.
Okay, I'll start doing that then.
Yeah.
Okay.
Yeah, just write it down on a password, on a notebook. You know, this is a password.
Okay.
Yeah.
I'm
All
gonna
right. Thank you, Professor.
No worries, no worries. All right, I'll see you guys on Thursday.
Yep.
All right, bye.
Have a great day.
Bye, Professor. Thank you.
Bye.
Yeah, thanks, Professor. Professor, one more thing. You said
Yeah.
you said I could get a couple extra points for that question.
Well, I didn't say a couple extra points.
Okay.
Yeah, just send me an email, okay? I'll take care of that.
Okay, thank you so much.